Welcome dear students to my channel. So today we'll see our next set of problems, that is the problems from question number 6 onwards for exercise 17a. Alright, so the first question of the day, question number 6 says, in the figure, AB is the common chord of two circles. So there are two circles, one's this one with center O2 and the other circle with center O1. Alright, now AB is the common chord, means this AB is chord for both circle with center O2 and circle with center O1. Alright, okay, so if AC and AD are the diameters, so AC and AD are diameters, prove that DB and C all are in the same straight line. Okay, now in order to begin with this, let us see what can be done with this particular circle. So in this case diameter is given, so if diameter is given, then the circle can be divided into semicircle, right? And there is a famous theorem which says angle in a semicircle is 90 degree. So in this I'll search for angle in a semicircle. Obviously this angle has to be this one, that is ABD, right? So ABD will be equals to how much? 90 degree. All right, similarly we have in this AC is the diameter, that means this part is the semicircle, right? That means ABC has to be again 90 degree. All right, so given is this one, right? So we have, as I said, AC and AD are the diameters of the circle, so we need to prove that D, B and C all are lying in the same straight line. So as I said, AO1C, okay, AO1C is the diameter, right? So if this is my diameter, then this angle has to be how much? 90 degree. So that's why angle ABC will be 90 degree, because it is the angle in a semicircle, right? Okay, now the same thing happens with the other circle as well, right? So we have similarly ABD, that is this angle will be equals to 90 degree. Now let me add this angle that is ABD and ABC. Let me add them. Okay, so adding them I'll get how much? 90 plus 90, which is 180 degree. Now 180 degree is also known as straight angle, right? So that means this angle is a straight angle, because this and this, when they are adding, I'm getting 180 degree. That means this is a straight line, right? So that's why DBC is a straight line. So DBC is a straight line. That means all this point, that is D, B and C, are lying in a same straight line. So pause the video to note down. Okay, so let us have a look at 7th question. So 7th question says, in the figure given below, that is this figure, find BCD. So BCD is means this angle, ADC means this angle, and ABC, that is this angle. So we need to calculate the angles, this one and this one. All right, now before I begin, let us observe our diagram carefully. So there are two arrows given in this way. So this means that these two sides, that is this and this, are parallel to each other. All right, now next thing that we observe here is ABCD is a cyclic quadrilateral, because all the vertices are lying exactly in the circumference. All right, now with this let us begin. Now there's a famous theorem in cyclic quadrilateral which says that so the opposite angles of a cyclic quadrilateral will be 180 degree. All right, so we have this angle plus this angle, that is A plus C, will be equals to 180 degree. Fine, so that means angle C is equal to, so angle C will be equals to 180 minus A, that is A is 105, so this turns out to be 75 degree. So that means angle C, that is this angle, means BCD, will be equals to 75 degree. So we are done with the first part. Okay, now we know that DC is parallel to AB. All right, now if these two are parallel lines, then we know that this line, the line which cuts the two parallel lines, is known as a transversal. So similarly this is also my transversal here. All right, now there is a famous theorem which you have learned in your junior classes, which says the sum of the angles formed in the same side of the transversal will be equals to 180 degree. All right, so that means these two are parallels. So this is my transversal, right? So the angle formed by this transversal are this and this, right? So when they are added, you will get how much? You will get 180 degree. Okay, so as I said, ADC, that is this angle, plus DAB, that is this angle, when they are added you will get 180 degree, because angles on the same side of the transversal of the parallel lines. All right, now we need to find the value of ADC, right? So let me keep ADC out here, let me take this out there. So we have 180 minus DAB, and how much is DAB? DAB is 105. So let me put DAB equals to 105. So 180 minus 105 is again 75 degree. So the value for this is also turning out to be 75 degree. Now so far we have seen how much is this, now we are left with this part. All right, now again we'll make use of the first theorem again, that is the angles of a cyclic quadrilateral will be 180 degree. That means B plus D will be equals to 180 degree. So that's what we are going to use here. So angle B is this one, that is ABC, plus angle D is ADC. So when they are added you will get 180 degree, because they are opposite angles of a cyclic quadrilateral. All right, now we already know what is the value of angle ADC, which is 75 degree, right? So if I put the value of angle ADC, then angle ABC turns out to be 105 degree. All right, so we have found the value of this and this. So pause the video to note down. Okay, so the next question, that is question number 8. Kindly observe your diagram carefully. Let me tell you in the beginning itself, this OACB is not a cyclic quadrilateral, because these three lie in the circumference, but this is not lying in the circumference. So this is not a cyclic quadrilateral. So kindly engage your mind in order to solve this particular problem. All right. Okay, so I have not told anything about question number 9, so you will try question number 9 by yourself again. Let's move on to the question number 10. So question 10 says, in the figure given below, ABCD is a cyclic quadrilateral, in which, so ABCD is a cyclic quadrilateral, so BAD is given to be 75 degree. So that is this angle BAD is given to be 75 degree. ABD, so only this much is given to be 58 degree, and ADC is given to be 77, that is ADC, that is from here to here. Okay, so this whole angle is given to be 77 degree. So we need to calculate these three angles here. All right, now since this is your cyclic quadrilateral, we can definitely find this angle, because sum of these two angles, that is A plus C, will be equals to 180 degree, right? So we have 180 degree because they are opposite angles of a cyclic quadrilateral. So we need to find this angle as well, because they are saying find BCD. So BCD means we need to find this angle. So this angle will be equals to, so angle A is 75, right? So 180 minus 75 is 105. So that means angle C, that is angle BCD, will be equals to 105 degree. All right, now another angle they are asking is BDC. So BDC means only this much from here to here. All right, now one more thing we know is from here to here, this whole angle is 77 degree. All right, now if we are able to find only this angle, okay, then we subtract this angle from this 77 degree in order to get this particular angle. Okay, now let us see how to do this. Now let us observe this triangle carefully, ABD, because we know two angles, we will be able to find how much is this angle. All right, so in triangle ABD, some of the angles will be 180, right? So let us put the values out here. So we are interested in finding BDA, right, or ADB, so whichever way you call it. All right, so basically we need to find the value of this angle. So let us put the values. So BAD is 75 degree, ABD is 58 degree, right? So we need to calculate this. So after calculating this, you will get ABD equals to 47 degree. All right, now we found it, this angle is 47 and from here to here is 77. So that's why my BDC, so angle BDC will be the 77, this 77 minus this 47. Okay, so this will turn out to be 30 degree. All right, so we have found it our second answer as well. Now let us go to the last part, that is angle BCA. That is BCA is this angle. All right, so this angle we need to calculate. If you see here carefully, if I see this line AB, or if I see this AB as the chord, then this chord divides the circle into two segments, that is this segment, this smaller segment, and the rest of the segment. Now let us see whether there are angles in the same segment. Okay, so we see that this angle and this angle are being formed in the same segment, right? That is segment AB, right? So that's why ADB and BCA both will be equal to each other. All right, so we have these two are equal because they are angle in the same segment, that is segment AB. All right, so we know the value of BDA or ADB, right? So ADB was turned out to be how much? 47 degree. So that's why my value for BCA will also be 47 degree. So pause the video to note down. Okay, so kindly try this problem also at home. Okay, so in question number 12, it is given that CAB is equals to 75 degree. So CAB, that means this full angle is given to be 75 degree, and CBA is 50 degree, that is CBA. So this angle is given to be 50 degree. We need to calculate the value of DAB. Let us see where is DAB. So DAB, that means only this much. All right, so only this much plus ABD, that is ABD, that means this much. All right, so this angle and this angle we need to find and we need to add them. All right, now in order to do that, let us see where does these two angles lie. So definitely DAB and ABD both lie in this particular triangle. If you see here, that is triangle ABD, because in triangle ABD we have DAB, that is this angle, right, and ABD also, that is ABD, that is this angle. All right, so we need to find the sum of this angle and this angle. Now from the diagram we clearly see that we have to use very famous theorem, that is angles in the same segment are equal. All right, because we see that this AB is a chord which divides the circle into two segments, that is this, and this AB is making two angles in the same segment, right? So that is this upper segment. In the upper segment, this AB is making two angles, that is this angle and this angle. That means they must be equal to each other, right? So let us first calculate how much is this. Okay, let us calculate what is the value of this equal angles. All right, so let us first go to this particular triangle, that is triangle ABC, because in this triangle we have been given this angle and we have been given this angle. Definitely we'll be able to find the third angle, right? So in triangle ABC, so if I add all this, then find this angle will be equals to 180 degree minus this angle minus this angle. All right, so this turns out to be exactly 55 degree. So this turns out to be 55 degree. So this also has to be 55 degree because they are angles in the same segment. Okay, so this is also 55 degree, that is ADB is 55 degree. Now as I said again, in this triangle ABD, this angle plus this angle plus this angle will be again 180 degree, right? So 180 degree. So let us put the value of whatever we know. Okay, all right, so in this triangle ABD we know only this, right, which is how much, which is 55 degree. All right, so let me put the value of ADB, that is this angle. So this angle is 55 degree, right? So let me get this thing out here. So this becomes 180 minus 55, right? Okay, now 180 minus 55 is how much? It is 125. So we have DAB, that is this, plus ABD, that is this, will be equals to 125 degree. So pause the video to note down. So in question number 13, ABCD is a cyclic quadrilateral Okay, so A, B, C, D. Okay, so A, B, C and D, all these vertices lie in the circumference, so that's why this is a cyclic quadrilateral, and O is the center. Alright, so one more thing is given, that is ADC. So ADC means this angle is given to be 130 degree. We need to calculate BAC, so that is BAC, that is this angle has to be calculated. Alright, now let us begin with the sum. Since this is given to be cyclic quadrilateral, so let us make use of the theorem for cyclic quadrilateral, which says this angle plus this angle should be equals to 180 degree. Alright, so we have one more thing, that is O is the center, so that's why if O is the center, then AOB will be my diameter, which is sure. Okay, now as I said, sum of these two will be 180 degree, so that's why angle ABC, that is this angle, will be 180 degree minus 130 degree, that is this angle, which turns out to be 50 degree. Okay, so this angle is equals to 50 degree. Now since this is my diameter, then this becomes, and this upper one becomes your semicircle, and this automatically becomes, this angle automatically becomes 90 degree. Okay, so since this is my 90 degree, now in this triangle ABC, okay, in this triangle ABC, this is 90 degree, so that's why automatically this and this, when they are added, this has to be 90 degree. Okay, because this plus this gives me 90, and again with this, that is this 90, it becomes 180 degree. All right, so in triangle ABC we have ACB equals to 90 degree because it is the angle in a semicircle, right? So that's why these two angles, that is BAC plus CBA, has to be 90 degree. All right, now our aim is to find BAC, that is this one. Now we know the value of CBA or ABC also, right? So ABC is how much? 50 degree. So we have BAC equals to 90 minus 50, which turns out to be 40 degree. So the value of angle BAC is 40 degree. So pause the video to note down. Okay, so let's move on to the 14th question. Now this question is going to be a bit tricky out here. All right, so let's pay attention very carefully. Here it is given that AOB is the diameter, that is this is given to be the diameter, and AOC is given to be 110, right? So this is given to be 110 degree. We need to calculate what is BDC, that is this. Okay, so which is written as x out here. So we need to find the value of x here. All right, now if you see here carefully, we don't have any angle being formed in the semicircle, right? So we cannot use that particular theorem. All right, although we have semicircles, we don't have any angle made by this diameter in the semicircle, right? So we cannot make use of that particular theorem here. So let me go for another alternative. Suppose if I see this BC arc, okay, so this BC subtends angle BOC with the center, right? Okay, now this BC, okay, in the remaining parts, that is the remaining part means from here to here, right? So from here to here, this BC makes angle this one, right? BDC, right? So this means that this angle, that is BOC, will be the double of this angle. All right, so let us find what is BOC from here. Now we know that this is my diameter, that means this angle and this angle, when they are added, I will get 180 degree. All right, so we have AOC plus COB will be equals to 180 because they are linear pair, because they are forming one straight line out here. Okay, now let's find what is COB. So COB turns out to be 180 minus AOC, and how much is AOC? AOC is 110. So the value for COB turns out to be 70 degree. So that means COB or BOC turns out to be 70 degree. So as I said in the beginning, this BOC will be the double of this, right? So as arc BC subtends COB at the center and x at the remaining part of the circle, so we have COB, that is this will be double of this one, that is 2x, right? So from here x will be half of COB, and how much is COB? COB is 70 degree. So this turns out to be 35 degree. That means the value of angle BDC will be 35 degree. So pause the video to note down. Alright, so this is my next question, and this is going to be the last question for the day. So question says, in the following figure, O is the center of the circle. Alright, so O is the center, AOB is given to 60 degree and BDC is given to be 100 degree. So you need to find the value of angle OBC. So OBC means we need to find the value of this angle. Alright, now this question is also similar to the earlier one, because this arc AB is making AOB with the center, okay, and in the remaining part AB is making ACB angle, right? So that means this angle will be half of this one. The remaining part will be the half of the central angle. Alright, so that's why we will be able to find how much is this angle. Now this angle is given, that means this plus this will be 180 degree. Alright, so as I said, arc AB subtends angle AOB at the center and ACB at the remaining part of the circle. That means AOB, that is this, will be double of this, that is ACB, right? So from here, what is the value of ACB? ACB turning out to be 30 degree. Alright, so we found it ACB, that is this angle, which is 30 degree. Now in triangle DBC, so DBC, we know that sum of the angles will be 180 degree. Now let us put the values. So we have DBC is asked, right? That is this angle is asked. So let us put ACB. So ACB, that ACB will be equals to, or DCB also you can call it. So DCB or ACB both means same. So this is equals to how much? This is 30 degree. All right, so we have 30 degree, and we have BDC. So BDC is 100. So if I put the values, so ACB is, as I said, ACB is 30 degree and BDC is 100 degree, right? So from here DBC is turning out to be 50 degree. So DBC means this angle. So DBC is also known as OBC. So that is OBC will be 50 degree. So pause the video to note down. So with this we close for the day. Thank you very much.